Okay, here we are in a development environment, and I have opened up the Smart Cosmos Samples project available from GitHub. Here we can see the structure, the minimum structure, that is required for creating a server extension. We have the actual server extension class itself. We have the configuration that maps into the YAML file. Collectively, these three artifacts are all that are technically required in order to create a server extension. Let's start by taking a look at directory configuration. When we open up directory configuration, we can see that this class extends the abstract Smart Cosmos extension configuration. Extending this class automatically provides access for the enabled flag as well as the extension name that are mandatory in every server extension's YAML file. You can see from the previous lessons where we talked about the different decorations that can be applied. In this case, for the ApacheDS in this sample, we have a number of properties that are required, such as the top level domain, the second level domain, the name of the organization, as well as the port. And you'll notice that we've even decorated the port to be a minimum value of 1025, meaning that we're operating above the server restricted ports of 1024 and below. The various getters and setters, and that is literally all that goes into a configuration class for a server extension. So to recap, the creation of a configuration class requires a set of properties, what the values for those properties could be, and decorating them appropriately with something like a min or a max, and extending the abstract Smart Cosmos extension configuration. In fact, if we look at these properties, the working directory, the instance ID, the server password, if we go back over to our project tree and we look at the ApacheDS YAML, we can see the instance ID, the organization, the top level domain, the second level domain, all of the properties that we just described in the configuration file. At this point, by defining the configuration file and the sample or default values for your YAML file, you've completed effectively half of the work in creating a minimal server extension. Now if we turn our focus back to the other half of the equation, we want to look at how to create the Java class for the server extension itself. Once we've built the configuration, in this case our directory configuration, and we've defined our YAML, we're ready to turn our focus to creating the server extension. The server extension must extend abstract server extension. And you'll notice how it is a generics class. So the name of the configuration file that we just defined has to be passed through into the base class. That's why it's important and easier to start with the configuration when creating a server extension, even if it's just a bare bones configuration, than to start with the server extension class itself. If we take a look at the abstract server extension, here we can see that our configuration must extend abstract Smart Cosmos extension configuration, which is where the mandatory requirement of the base class that we just looked at came from. We can also see that our abstract server extension does implement iServer extension. And if we look at the iServer extension class, the interface that is, we can actually see that the interface itself has a number of key features that are important to understand when creating server extensions. In the previous lessons, we've learned about resource registrar. And we know that the resource registrar is where we can register either additional DAOs or we can register additional endpoints, and that the context is passed into the resource registrar interface. Because iServer extension extends iResource registrar, every server extension has the opportunity to register DAOs and endpoints. We also can see that this extends the managed interface from DropWizard. The managed interface from DropWizard is where we have a start and a stop method that is automatically invoked by the DropWizard framework whenever a class is decorated with managed. which gives the server extension the ability to launch or connect to long-standing resources and properly shut down or release those long-standing resources. Finally, every server extension must be identified with a unique UUID. It's critical that these UUIDs are truly UUIDs and that they are unique across the spectrum. We also have to give a logical human-readable name to the server extension, and then we have access to anybody who looks up this server extension to the configuration of that extension. Finally, if the extension is going to contribute new database entities, the list of entities that it's defining can be fetched and will be fetched automatically by the object's runtime at Bootstrap from the getEntities method. So on the surface, the actual required methods for iServer extension are fairly small. You have your extension ID and your name, which will be handled by the base class's constructor. You have the configuration, which is also passed in with generics. And then finally, the list of entities. When we take a look at our abstract base class, we can see that we automatically will store through the protected constructor the extension ID, the name, and the class type of your configuration automatically in this base class. So thus, those methods are automatically taken care of. We can also see that the getExtension configuration is automatically taken care of by the base class. And there is a default initialize method which automatically will use the dropwizard bootstrap routines to go load the configuration file specific for this server extension. In our case, that is the ApacheDS.yaml that we just reviewed in the last section. The initialize method is stubbed out to be empty in the follow-on call. You can see here that the bootstrap initialize will automatically invoke this initialize with the configuration. Thus, the server extension developer doesn't have to worry about how to load the YAML file. The framework will load the YAML file, and it will pass the resulting bound extension configuration into this protected initialize method. We also have a run method, and the run method is where we can launch the server extension. This is also linking back to dropwizard itself from the io.dropwizard.configured bundle. So that's taken care of. The register resources has a stubbed out entry, so assuming there are no DAOs and no additional endpoints, no specific override is required for register resources. The same thing can be said for getEntities, start, and stop. Thus, when it comes to creating our server extension, the only thing that typically is required as a bare bones or hello world is the call to the super constructor, where we pass in the extension ID, a human readable name for the extension, and the class type for our configuration. And then in the real world, in most cases, the initialize method with the configuration is passed in. Here we can see a best practice. In the initialize method, we always check to see if the server extension is actually enabled. Well, this is not programmatically enforced anywhere. It is a strongly recommended best practice. There's a reason why every configuration for every server extension offers an enabled flag. If the extension configuration is enabled, then we actually initialize the server extension. Otherwise, it's polite to just log out that the service has been disabled as per the YAML configuration file. In our case, we're setting up an LDAP server using the ApacheDS open source LDAP server. So we launch a default directory server, we go through defining the server's behaviors and its partitions, we start up the server, and then we confirm or update the admin password. You'll notice that if there's an exception anywhere in this startup process, it is important that that exception be rethrown. If the developer fails to rethrow an initialization exception, then dropwizard will continue to start as if there were no problem. Since we know that the directory service is a key service in the objects framework. It doesn't make any sense to allow the server to continue to start if there was a problem with the directory service. Therefore, it's critical that the developer understand that they must rethrow an exception after logging it to ensure that the server does not continue to start without an actual functioning, working directory service. In our case, we also override the stop method, shutting down the server that was spun up and shutting down the directory service. The stop method is important because we want to properly release those resources that are being used by the ApacheDS server. In fact, if there were any open file handles or such, it's better to give the embedded server the opportunity to do a clean shutdown than to just throw it away at the end of a process. There's also a whole bunch of private helper methods that are very ApacheDS specific. As our intention here is not to teach somebody how to build or implement ApacheDS, but instead to focus on the server extension, we're not going to go into the details of the ApacheDS server implementation. So in recap, every server extension must extend the abstract server extension. It must invoke the super constructor, passing in a UUID, a human readable name, and the configuration class. In the real world, the initialize method will be overridden, and a decision will be made on whether the extension is enabled or not. And if there is a problem in a service extension, such as being sure that the server extension works, that the service extension might be relying upon, we do want to throw out and rethrow that exception. In short, server extensions are not black magic. Server extensions are a way to provide new functionality into the objects platform. The actual functionality that is provided by a server extension can vary dramatically. In this example, we saw how we were able to take an ApacheDS LDAP server and successfully use a server extension to define a configuration file, a YAML file, and a small amount of code to wrap an LDAP server and to make that available to an objects platform as a server extension.